problem we're asked to set up and simplify a difference quotient, and the particular function is given to us to be a root, the square root of 3x minus 2 to be exact. Each of these problems really does have two steps. First you set it up and then you simplify it. And while simplify can often be a vague term, in this context we're usually after a simplification that will allow us to cancel the h in the denominator. We will be particularly interested in the value of this quantity, this quotient, as h gets very close to 0. And in its current form, you can see division by 0 or something very close to 0 is going to be a problem. The overall quotient here will be hard to define when h is very near 0. So our goal here is to perform some algebra steps to try and get this h to cancel with an h that appears in the numerator. And of course, to cancel with something in the numerator, it's going to need to be a factor of the numerator. So our goal here is to set up this difference quotient and rewrite it a couple of times to try and find a way to get the h to factor out and cancel with the one in the denominator. Many of these problems are similar, so as you're going through a problem like this, you want to not only look at this particular problem, but be on the lookout for some structure that you can use when you run into similar problems. First is the setup. And regardless of the function, we are asked to evaluate it at g plus, the name of the function is g. We're asked to evaluate it at x plus h. We're also asked to evaluate it at x and subtract the two quantities. This particular function takes whatever number I give it, represented by the letter h, or the letter x, sorry, and returns the square root of 3 times what I give it minus 2. So if I give it the quantity x plus h, you view that as a single quantity, then it's going to return the square root of 3 times that quantity, x plus h, minus 2. So that is the first piece of this. And then we subtract from that what we get when we evaluate at x. So right now, this minus sign is this minus sign, just to help keep track of where everything's going. We now subtract from that g evaluated at x. And again, if I evaluate this function anywhere, it gives me back the square root of 3 times what I put in there minus 2. Now the numerator here does have an h in it, but the h is buried underneath this root. So our goal here in our next step will be to attempt to find a way to remove the root. I cannot simply square every quantity here, but that's the net effect I would like to have on this. So I'm going to multiply by something that has that end goal. And so over here to the side, I'm going to remind you of a key fact. If you have a difference of two quantities and you multiply it by the sum of those two quantities, so a minus b, if that's what you start with, if you multiply it by a plus b and multiply this out, you get an a squared from the a times the a. The inner and outer terms add up to 0. There's a minus ab and a plus ab, and then there's a minus b squared. And so you can see what's happened here. I started with a minus b. I ended up with a squared minus b squared. And so if we apply this logic to our problem up here, I can multiply this numerator by the sum of those two quantities, which is called the conjugate of those two quantities. And that will result in something that has squares on each of these. Now, whatever I do to the numerator here, I'm also going to have to do to the denominator in order to preserve equality in the algebraic expression. So I'm going to square root of 3x plus h minus 2 plus the square root of 3x minus 2. So that's the a minus b times the a plus b. And again, since I did that in the numerator, I'm going to need to do that in the denominator as well. 3x plus h minus 2 plus square root of 3x minus 2. And my goal here then is to factor, I'm going to leave the denominator factored because I eventually want to cancel this h. So I'm not going to multiply out the denominator, but I am going to multiply out the numerator so that I end up with no roots involved in the numerator. So there's my denominator. The numerator again will be the first item times the first item, which will be a square root times the square root, which is just the quantity underneath. The cross terms here, the inner ones and the outer ones, end up adding up to 0, and I get a minus square root of 3x minus 2 times square root of 3x minus 2. And be very careful here. That's minus 3x minus 2. You got to use parentheses here or carefully distribute that minus sign as you go. I like to use the parentheses and come back and simplify it again on the next step. So I've got no more roots left in the numerator. I have the h factored out in the denominator, and I am now going to multiply out the numerator in an attempt to combine like terms. I have a 3x, a 3h, distributing that 3 through. I've got a minus 3x and a plus 2. It's minus a negative 2 will be plus 2. And what you should see here when you get to this step on for any function is a bunch of things adding up to 0. The minus 2 and the plus 2 add up to 0. The minus 3x and the plus 3x add up to 0. So all that's left in the numerator now is a 3h. In the denominator, I've got my h, I've got my square root of 3x plus h minus 2, and I've got the square root of 3x minus 2. This h now can cancel that h. I'm assuming h here is not exactly equal to 0. And that leaves me with the simplified form that I was looking for. Now, in the next investigation of this sort of problem, what we would be asking ourselves is not just what is the simplified form of this difference quotient, but what is the limit as h goes to 0 of the simplified form of this difference quotient. So technically I'm done with this problem right here. It's as simple as that gets.